Biophilic design for healthy and stress-free buildings. My name is Annebeth Muntinga, and this is my colleague Maria Sara di Maggio, and we are building physicists and sustainability engineers at ABT. ABT is a multidisciplinary consultancy firm, and we do total engineering for clients like architects, developers, municipalities, and multinationals. Next slide.
It's
some technical issues.
Yes, one moment. Yeah.
Yes. When we define biophilia, it's the term coined by Harvard naturalist Dr. Edward O. Wilson and describes what he saw as humanity's innate tendency to focus on life and lifelike processes and to be drawn towards nature, to feel an affinity for it, a love and a craving. And it fits within shifting the focus from energy use inside buildings towards human beings. Because if we look from the human's perspective, and we look at the Maslow pyramid, you see that many companies focus on the top part of the pyramid, esteem and self-realization. But you can only fill in these layers once the ones at the bottom have been properly addressed. And this is where building physics, MEP, architecture, fire safety comes in, and also where you will see the biggest effect of biophilia. Because the main causes for deficient productivity, they include absenteeism, loss of focus, a negative mood, or poor health, while the requirements for a pleasant work experience are a need for change, the ability to control the environment, meaningful stimuli, one's own territory, and a view to the outside world. And most of you will probably be calling in from home, but think back about your own office. Which needs does it fulfill? Is it really giving you a pleasant work experience? And why do we need to know this? Well, the financial losses due to absenteeism and presentism account for about 4% of a company's cash flow. And absenteeism we know as people being sick, having a burnout, while presentism describes the phenomenon in which workers do clock in for work, but are mentally removed from the workplace. And overall, this is a financial loss of 4%. Next. So today we're talking about how we're going to bring the outside world to the inside. And now Maria Sara is going to take you through some strategies and biophilic patterns of how to do this.
Thank you, Annabeth. So how can we bring the outside world inside? Biophilic patterns come in to help. They've been defined for the first time in 2014 by the research group Therapin Bright Green, an American consultancy that collected all the available evidence on health and well-being related to biophilic design and structured the patterns into 14 items, which are categorized in these three main areas: nature in the space patterns, nature analogues, and nature of the space patterns. Let's dive it in. So nature in the space patterns relates to the direct connection with nature through the presence of water feature, of dynamic diffuse light, but also sensory stimulus. Some examples are here, Singapore Changi Airport, where literally nature has been brought into the space, simulating this tropical forest and waterfall, but also in a more subtle way, the Louvre in Abu Dhabi, where diffuse lighting is created through a complex ceiling. But also nature in the space can be brought through odors and sensorial stimulus through flowers, vegetation. Nature analogues relate to the evocation of nature in the space by means of ornamentation, artwork, textiles, and recreating these elements within a complex order as the one we find in nature. Some examples here, the Hermes shop in Paris, where these organic shell boxes are recreated with timber elements, but also in a more subtle way we can have fractal patterns, such as in the shard in the top right picture, where this cladding is used to recreate a sort of refuge area into nap room, but also more within ceiling and flooring through natural elements like in the top on right image. Natural the space patterns relate to a design of deliberate engaging elements of interest of the space. So by looking at concepts such as refuge, mystery, risk and peril that can be introduced into the space, like in this example from Álvaro Siza in Portugal, the Faculty of Architecture. We see on the top left image the circulation area which leads to an unknown space, and this is an element of mystery. But also on the right image, we have an example of the library of the same faculty, where these desks are located on the top floor. They have a prospect of view to the library, but at the same time they're protected, shaded by the skylight on the right, on the left, and the bookshelf. So somehow it gives a sense of sheltering. And below, an element of risk, which could be a complex staircase, which triggers an element of risk and peril, which is relieved once we arrive at the end destination. But the important thing about biophilic pattern is that we can combine them together, and we can also scale them to the environment we want to use them for. So, for instance, they can be used on a room scale, but also on a building scale or on a campus, on a landscape design. And this is an example in the schematics on the bottom left, where we enter into an office room, for instance. We always try to look for the seat which is more shaded, protected, more private, but at the same time that has a view on the outside space to kind of monitor the situation. And this is important, is the element of refuge and prospect that can be modulated by the back high seat in order to ensure that when you look for a space, for instance, you don't create discomfort by entering too much into the space of the sitting areas. So several research have been conducted in order to address this link between biophilic patterns and health and well-being. And this relates to the so-called sick building syndrome, which we often experience in indoor spaces due to, for instance, the lack of contact with nature, but also due to the outside which are lacking, or condensation problems, respiratory issues. And Terrapin has kind of defined these three main overarching systems which relates to health and well-being. So we can see that the effects on health and well-being relate to cognitive performance, so the mental agility, the memory, everything that relates to the ability to think logically and creatively. But also there are aspects of attention, emotion and mood, so the psychological health. And then we have the physiological health, which relates to the physical comfort that we experience into spaces, the respiratory capacity or the circadian rhythm. So these visuals show how these three main areas of health and well-being relates to the patterns, the 14 patterns, which have been distinguished by color. So you can see immediately that the patterns that have the most impact are the one in yellow, which are the nature in the space pattern that have the direct connection with nature through diffuse light, to thermal flow, to presence of water. So these are very effective, and research is quite robust in this sense. Whether when we look at stress reduction due to natural analogues are not so much supported by research as the other patterns. Still, the research is in infancy, and we need to be aware of that. Then we have mood and emotion patterns, which are the ones that relate to the engaging layouting of the space. But beside that, there are also elements of biological processes that we need to be aware of when designing biophilic strategies. We wanted to show you this simple process of phytoremediation, which is the process responsible for the reduction of contaminants and toxic elements through air, soil, or water. And he relies on the power of the roots of the plants, which can store and curb and break down the contaminants. And this is a simple process that is at the base of the many strategies that we see when we integrate nature into the space, so the reduction of contaminants. Also, we have biofiltration, which is a pollution control strategies which merge the power of the roots of the plants with a ventilation system. It needs a surface to be effective, so this surface should be made of compost or soil or nutrients from plants. And this is very effective in mitigating the VOC levels, the VOC concentration to the space. VOCs are the volatile organic compounds, which we find in furniture, in finishes. They come from printers, and they're in high concentration. They can be quite toxic for the individuals. So let's step back one moment to the Maslow hierarchy. So we see with Annebeth that with building physics, with architecture, design, we can cover the base of these pyramids. With biophilic design, we can reach the top by applying also circular resource strategies, design layouts, sensorial aspects. And we want to show you this framework, which we develop, which encompass the different strategies that covers biophilic patterns, and they can be merged in these three main categories: sensorial architecture, which covers design layout and sensorial aspects, climate control and efficiency, so everything that relates basically to building physics, and circular use of sources, so water use, food production, and support. Strategies of sensorial architecture. In natural ecosystem, they are more resilient when they have a diversity of spaces, of functions. And this can be reproduced in the indoor space by soft boundaries, by diversity of furniture, by creating zones where people can collide, collision spaces when they can talk casually, or they can just meet each other, or also creating spaces where they have more gathering function. And this is basically the same patterns that happen in nature in a different way. Then we can have non-rhythmic sensory stimuli strategies. This relates more to our capacity to focus, to be alert, and can be enhanced when we position on the peripheral areas elements of nature, such as a water feature, plants, or a bird stimuli that needs to be non-rhythmic. So they need to be casual, they need to be natural, organic in a way. And in this sense, we can relax our focus from the task we are doing for a few seconds, and that can have an element of restoration in our task work. But then we have also olfactic stimulus. So the sensation of odor is very subjective, and the odors depends on a range of factors. That depends on age, the sensitivity of the person, the gender, the expectation of having this smell into the space. The odors can be classified from more offensive to less offensive. Some odors, like coffee, brewery, bakery, is not as offensive of waste and gasoline odors and others. So they are really classified and weighted in a scale, and we can actually mitigate or enhance some of these odors in the sensorial architecture strategies. How can we modulate these odors? There are the webs that come in to help, so vegetative environmental buffers. They're divided into two main areas. So living biofilters, we've seen the process before. So the principles as using the plants to intercept and break down the contaminants. But in this sense, dust is the sort of conductor of odors. So when we break down the dust, when we work on the dust element, we can reduce the element of odor in the space. Another way is windbreak, so by dilution of odors through air ventilation. We can also simulate it. Here on the left, right, you can see a simulation of a fume coming from a hood, and we can check the different effectiveness of the strategies we apply through CFD modeling, for instance. Overall, sensory architecture has effects on health and comfort. We have here listed the main areas of impact: concentration, spatial pleasure of the space, and productivity. Then let's move into climate control and efficiency. So this area covers mainly building physics. Some strategies are active green walls, which is basically a combination of having a ventilation system, recirculating system with a biofilter. So the air passes through the roots of the plants and it breaks down the VOCs, the compounds in the air. And in this sense, we are reducing the amount of fresh air we need in the space. We are reducing in cost for installation, but also elements of installation, provision of installation into the space. Of course, these systems require an irrigation design for the plants. It needs to be maintained, so it's not so static a system, but it needs some taking care of. Then we have passive wall systems, which are basically work as standard acoustic panels. Their potential for acoustic for sound absorption and scattering depends on the density of the plant coverage, the substrates, and the ways in which they are designed, they are introduced into the space. And even here we can simulate them with CFD modeling and model the boundary condition they are applied within. Then we move into thermal comfort. So there are areas in nature, we have a diversity of climate zones, microclimate, macroclimate, and this can be recreated in the space by allowing certain areas to have a bigger range of temperature gap where people can adapt. They're not feeling discomfort by having this differentiated temperature. But there are areas that require some more stable temperature. We have here an example of the university building in Utrecht. For instance, the circulation area where people step in is an area where you still have a jacket, you still are coming from the outside. You don't expect to be comfortable, totally comfortable there. And it's acceptable to have a bigger range of temperature in that space, even the margin of 10, 15 degrees. Whether when we come into mixed areas where people are sitting and maybe exchanging some words, or they're spending some time but still is temporary, then we can have a smaller temperature range set point. And then we have the working seat where we can allow a more stable climate, but also diversify it by zone. So natural light. Since history, the effect of natural light into the individual is quite determinant. The views to the outside in a hospital, for instance, have produced quicker recovery levels than people that didn't have this view to the outside, to the natural world. And in office spaces, for instance, being exposed to natural light can enhance creativity and ability to think logically by 50%. But what happens when we use artificial lighting, and then we have these patterns of relation to the outdoor climate starting to miss. So in the natural light, we have a range of colors according to the wavelengths. So it's more yellowish in the morning, bluish during the day, and then on the orange spectrum in the afternoon. We can recreate these sort of wavelengths through circadian lighting. And in this sense, we can ensure that our body function quite as in the outside world. So by having more boost, more energy in the morning, and more relaxed feeling in the afternoon. This can be done through sensoring, smart sensoring, and application of devices on desk level, on walls levels to monitor lighting levels. So overall, these are the effects on health and well-being as what regards climate control and efficiency strategies. Now let's move into circular use of sources. Here we cover more the water use and the edible plants into the space. Halophyte filters are an example of a phytoremediation process that we've seen initially. They are basins in which reeds and plants are filled in, and they can break down nitrates and phosphorus from the ground. They can really clean the rainwater, and this rainwater can be redirected to be reused for indoor water demands, such as flushing toilets or irrigation or other purposes. A problem of this type of strategies, though, is that it's has associated with high level of humidity, so it's generally more appropriate for outside spaces. Then we have biophilic wastewater reuse. So this is an example of a living machine designed by John Todd, American consultancy, and they have this system of basins that basically cleans black water and eliminates the odors of black water. And this water again can be reused for different functions. And then we have the elements of edible plants. So although this might look like a more let's say, hipster way of applying vegetation to the space, actually is the one that has one of the most beneficial effects on health and well-being, because interaction with plants, taking care of them in a more engaging way, has the most benefits in terms of a reduction of blood pressure and stress relief. And this can be applied to organic agriculture, recreational activities which involves the presence of plants. So overall, the circular use of sources can have an effect on heart rate, blood pressure, positively impact attitude and comfort. But what happens when we look at the broader spectrum of the certification levels? So with BREEAM, with WELL, with LEED, they all take into account biophilic design now more than ever. For instance, BREEAM has introduced a credit this year just for biophilic design. WELL take into account biophilic design different credits, and LEED as a pilot credit for it. So when we look at certification, by implementing biophilic design, we can actually gain also more points on these areas and increase, therefore, the building value. So here we wanted to show you a quick example of how we can implement this framework, biophilic design. We didn't look very far for this case study. This is our office in Velp, ABT office. And that's the canteen, the space we eat, where we spend time, lunch time, mainly before Corona arrived. And then how can we improve this space? Can we think of maybe introducing active green walls, which can clean air, but can also absorb sound, and they can ensure that the ducting system is reduced, and also have a visual benefits for people when they as a health and well-being design strategies. What about shading this very bright light through a smart shading system connected to sensor? Maybe we can think of modulating the lighting as to avoid to have discomfort due to contrast and high brightness levels. Can we think of a more organic way of organizing the seating around the canteen? Maybe looking at the back seat high and thinking how can we reproduce the natural world inside, and creating areas which are more private and areas that are more for gatherings, for instance. But then we can also look at artificial lighting, how we use artificial lighting in this space. Can we rely on the circadian system and follow the patterns of the day and the functioning of the body? So we can have areas with more relaxed lighting on the orange, yellowish range, and then area with boost energizing areas. And finally, can we modulate thermal flow and seat level rather than a set point for the whole canteen? So people, when the canteen is not fully crowded, some seats are off, some seats are on, and on seat level, thermal flow can be modulated according to the person control. So finally, what we've seen today is that biophilic patterns can really have a huge impact in our work as engineers and designers. Patterns shouldn't be considered extras, but can be implemented quite smartly into the design of the space to enhance comfort. Maybe we can also introduce some psychological supports when talking about targets and goal of design. And maybe also discussing more with biologists or agronomists to have their expertise on the type of plants and boundary conditions that work best with certain vegetation types. And in the end, we should really measure the benefits and the cons of having biophilic design towards a more conventional system. Thank you very much.
Thank you. Okay, with that, we will end this webinar. Thank you for attending, thank you for listening, and have a nice day. Thank you
very much.